with the pump introduced to the heat exchanger. In this heat exchanger, we increase the temperature of crude oil to be able to remove better salt from the oil. And after that, we introduce water inside of that with the oil and mix with it into the dissolver. How can we increase up the temperature of oil here with this boiler? There is two types of heating media in the refinery which is common in our country. The steam heating system and hot oil heating system. If you have a hot oil, the cold oil comes inside of the boiler and again return back to the heat exchanger to be able to heat up the oil, crude oil. Crude oil enter here, as you see, you have the electromagnetic field to settling better and increase the efficiency of separating in the dissolver. As you see, we can use electrical power as the final phase of separation. Every dissolver consists of three sections. The first section is inlet diverter and inlet separator. Then we have to give a retention time to be able to separate two phases, oil and water from each other. And the last section consists of electromagnetic field to be able to knock out all fine water droplets which dissolve in the oil. Okay? When you start to distribute a lot of electrons in a grid, electrical grid here with high voltage, low ampere, what happened to that? Electrons, the number of electrons in this grid is very high, in the water is less. Therefore, like welding rod, as you see, electrons want to fly to the other side and the metal start to melt. What is that? Electrons want to fly from high potential to low potential. But here, the ampere of electrical power is very low. We have not any fusion, any melting, but the electrons want to fly from this side to the water side. What happened that? The water's droplet, fine droplet, want to carry away with the oil, but the electrons push them, punch them like hammer. Comes down, and all the water droplets settling here, and the final separation happens. After that, we have a relative time to get a more retention time to the oil, and then oil enters from this side to the final stabilizer. There is two types of specific final stabilizer in the oil and gas industry. The first type is a simple separator, and the second type is the distillation tower, like that one. You see over there. Distillation tower, we use distillation tower when we want to adjust the amount of H2S in oil, less than 20 ppm. Okay? In this case, we have to use a distillation column, especially reboiler stripper type. Reboiler stripper type, it can completely remove light component and H2S from the oil. It is very useful, the distillation column for shipping. But some high quality oil like Vescorna, like Majnoon oil, it is suitable to be separate from the light component with a simple separator. And we return back and we wrote that to the final product storage time. It is ready to send your product anywhere you want. As you see, we have a custody transfer after this one. That means we process oil, and after that we have this amount of oil. We have to count everything here to get money from the buyers. Okay? Therefore, in the downstream of this tank, always we install a pump station, blending station, and custody transfer. It is very important to us to know about the flow transmitting in custody transfer. This is a simple separator which can separate water from the oil. We can see here. This is which type of level gauge is that? Magnetic type. This is a level gauge magnetic type. It has a magnet here. When it gets out of calibrate, you can easily slide the magnet here and you can calibrate it easily by the site operator. This is high quality, very expensive, but very valuable level gauge transfer. Yeah. This is the dehydration system. This is a TEG system. TEG, 3-ethylene glycol dehydration unit. In the gas or oil processing, sometimes we decided to absorb more water. For example, for export quality, it is necessary to keep the water content, water dew point less than -10. For example, if you want to send your gas to Turkey, the dew point should adjust it on -10. This is the minimum temperature which achievable in Iran, Iraq, Saudi Arabia, Kuwait, and like this oil country. This is the minimum temperature achievable in depth of 60 centimeter underground. But for some special purposes, we decided to reduce the dew point less than -10. For example, -35 for condensate removal, for LNG separation, liquefied natural gas, C5+. Condensate separation, you have to reduce the temperature down to -35 to be able to separate all condensate from or raw material. Therefore, if we reduce temperature, what happens to exchanger? If water is available over there, start to freezing at -35. Therefore, before that, we have to install dehydration, complete dehydration unit to be able to remove all water from the gas down to -40. We use a TG here. This is a remover, this is an accumulator, and this is a stick column. TG starting with the stick column. We reduce pressure here. The pressure in the absorber, TG absorber, is high. The working temperature is better to keep it between 45 degrees centigrade. The temperature of gas should be a little bit less than TG. And TG contact with the gas, TG want to absorb water. After absorb water, rich TG have to do the expansion valve and enters to the separator. We remove most of gas which is here, and the TG is rich with the water. Without any gas enters to the steam column over there, and in the steam column, most of water will vaporize because the vapors comes out from this side. From the reboiler, we pick up reboiler. The water in this vessel will